Hi, everyone. Thank you for tuning into our video. My name is Andrew. I'm excited to share our project, which we decided that we would like to tackle wildfires by designing an autonomous firefighting swarm.
My name is Nathan Merriam.
My name is Bernard.
My name is Daniel Town.
In 2022, around 64,000 wildfires have impacted roughly 7.5 million acres of U.S. land. With the voluminous amount of wildfires occurring each year, our team will be developing an autonomous robotic swarm that will increase the safety of fighting wildfires. Our design will add societal and environmental value by reducing the risk of incurred by human firefighters and protecting the environment. Looking at the stakeholders involved, our intended area of application is to assist any agency on any level within the United States, whether that's local, state, or firefighter department agencies around the US. Other relevant stakeholders that may indirectly affect this design would be investors, tax-paying citizens, and policymakers. Our design requirements, one of the biggest aspects that we need to be able to do is to be able to communicate with one another and direct each other around. So our swarm must be able to scan a 1 kilometer by 1 kilometer area under 10 minutes. Our swarm must be able to communicate to a central command hub. Our swarm must be able to recharge at a base station. Our swarm must be able to detect hotspots and direct appropriate robots to the site. Our swarm must be able to withstand 800 degrees Celsius, and our swarm must be able to construct a fire break at least 3 feet wide. And to quickly introduce each robot, the robot I have designed is the Fire Scout robot, and it is designed to scout for fires and communicate to the other robots where to go. Nathan designed the Liquid Death, which is designed to combat the fire by spraying water. We have Daniel's robot that will be mopping everything up, and this robot is designed to prevent reignition and clean up the fire contained area. And Bernard's robot is the robotic trench digger, which is designed to dig fire lines to inhibit the fire from spreading. My mechanical design, we have a carbon fiber composite drone frame, an internal housing with the microcontroller, the battery source, the Wi-Fi sensor, and RF transmitter. We have our 4 carbon fiber propellers here that are ran by 4 brushless motors to add some stability and support. Here we have our aluminum alloy leg stands. This is for better landings, to provide a little bit more structural integrity to the drone itself. Here are dimensional view here, with our height being 20 inches, width 30 inches, and our length 36 inches. And we also get a great view on our quad hybrid sensor camera, gimbal mounted here, with a zoom wide features, along with a rangefinder with LiDAR capabilities and thermal. So looking at the circuit design here, we have our ultrasonic distance sensor that is acting as our rangefinder within Tinkercad. We also would have our hybrid camera underneath. We can jump to our 2 motor drives that connect to our 4 brushless motors here that would connect to the carbon fiber props. We have our Wi-Fi RF transmitter here, temperature sensor to detect the human life resemblance, heat signatures to the highest heat signatures of where we need to direct as much of our focus as possible. We have our internal battery source here acting as these 2 9-volt batteries, and the brains of the operation, the microcontroller here. So looking at the process flow, the Fire Scout will respond to the fire. It will start flying towards the fire. It will scan for the highest heat signature using the wide and thermal imaging capabilities of the camera. If the area does have a high heat signature, then we will move down and send out a 1 kilometer by 1 kilometer coordinate grid to the central hub. to communicate with the other robots where to go and fight the fire. If it doesn't, we still want to scan for heat signatures resembling human life. So if there is resemblance of human life, we can toggle our camera to the LiDAR slash rangefinder to confirm and send out immediate distress signal and call the coordinates to the central hub if we do confirm that there may be human life in a surrounding area of the fire. We want to double check and make sure that our battery is above 25%. If it isn't, we want to fly back to the central hub to charge the battery. If it is, we circle back here. We go all the way back to starting flying towards other aspects of the fire. We're scanning for high heat signatures, and the process continues. We have here our setup. We can hit simulation, and we can see it's starting to run. Zoom out a little bit. We can see right now that everything is starting to run. Check here, and we can see the temperature sensor displaying on the serial monitor as it's going up and down. You can zoom in here too to see we have going all the way down, back up, zooming out here. You can see that the motors, based on the code, are going in opposite directions to maintain float here. And there we go.
For this project of fighting fires, I have designed the Liquid Death, the water robot. As you can see here, it is 85 by 116 inches with the inside diameter of the hoses of 5.2. There is a fill valve which connects to a water source, if there is one, at the back of the robot. There is a slight change made between the second deliverable and this one, which is that at the end of the hoses there is no hand. This hand was cumbersome and unnecessary, as the hoses can do whatever the hand can do. We need sensors and actuators, which are a GPS, ultrasonic, and temperature sensor, all located in the head of the robot, with a hose and foot actuator. The GPS sensor is telling the robot where it is and where it needs to go in accordance of the fire's location given by the central hub. The ultrasonic distance sensor tells it if anything is in the way of the robot when moving forward. And the temperature sensor is used in order to tell where the base of the fire is to best execute the water onto the fire. The hose actuator is used to control the pressure coming out of the hose of the water. And the feet actuators are used to give a jumping ability in case there are obstacles. It starts, it waits for instructions from the central hub of where the fire, and then heads that way once the instructions are sent. It uses its ultrasonic distance sensor and the GPS to tell it where to go, either to the nearest water source if there is one, or directly to the fire if there isn't. Once it's at the fire, it will determine if it's a hilly or mountainous or a structured landscape so that it can tell what pressure to use. Once it has the pressure, it will fight the fire using the ultrasonic and temperature distance to determine where the base of the fire, and it will continue spraying until it is out. Once it reaches 25% or less, then it will go back to home. If it still is more than 25% and there are no more nearby fires, it will go back to home. If there is more than 25% and there are still fires, then it will continue going to fires until there are no fires left to put out. Thank you.
For our firefighter swarm, I designed the trench digger robot. Here's the mechanical side. This robot is responsible for digging a fire line to prevent the fire from spreading outside the area. It has a receiver that communicates with the central hub to receive information and then sending it through different mechanism. It has a 5 feet wide body and 5 feet tall. It has track tires for better movement, and then it uses different distance sensors so it can navigate through the field properly, and it can avoid obstacles. And then at the front, it uses an excavator for digging. It's 3 feet wide and 2 feet tall. It has multiple cylinders so it can go up and down and forward to do its digging purpose. And then for the circuit design, there's two Arduino boards, one to process the GPS, and one is the main board that controls all of the motors, sensors, and servo. It has three servo motors to move the excavator or the flow assembly up and down and forward and back. Also, it has three distance sensors. It has two motors that's connected to an H-braid motor driver, and also it's connected to a battery that provides power to different components. At the beginning, it won't do anything unless it receives the pathing information from the central hub. Once it receives the information, it's gonna send the location to the GPS tracker, so it will calculate the starting point and then the distance, then proceed in sending the signal to the motors to move it forward. Once the robot gets to the starting point, it's gonna calculate for the end of the corner point, and then so once the robot is facing the corner point, it's gonna have the flow assembly ready. You're gonna send signal to the servo motors to go downwards, and then if it's facing the correct angle, it's gonna send another signal to the other two servo motors to push the excavator towards the ground. And then once it goes forward, it's gonna do this basically the same as this previous one, where it uses the sound sensor to locate obstacles and then to navigate properly. So once the robot is on the next corner point, once you repeat the cycle and then the robot location goes back to the starting point, it sends a completion signal to the central hub.
The mop-up robot is responsible for cleaning up an area after the fire has been contained. Smoldering embers pose the risk of reigniting the area, and the mop-up robot's job is to find those embers, break them up, and spray them with fire suppressant foam. It utilizes treads to help it navigate over difficult terrain. There are individual motors driving each of the treads. In addition, it has distance sensors to help it with collision avoidance and a thermal imaging camera to identify the hot spots. A manipulator claw that can open and close, raise and lower, will help break up the material and expose the embers to then be sprayed with fire suppressant foam from the nozzle. I utilized two Arduinos for control because the single Arduino did not have enough I/O for all the inputs and outputs. It's using a 2-wire I2C communication to transfer commands between each of the Arduinos. One Arduino controls the drive and pump functions, while the other controls the claw manipulation. Motors for driving are up here. This is the pump motor right here, and these are the claw motors for open and close. These switches are stand-ins for proximity sensors that would be on the claw. It receives pathing commands from the central hub, calculates the waypoint, and then drives while looking for collision avoidance. Once it is at the hotspot, it takes images with the camera and then proceeds to clean up based off the command received back from the central hub, and then it drives back to its home. The simulation will ask for an X and Y coordinate. This would be provided by the central hub, but here I am using serial commands. Once it has those coordinates, it will take its current GPS angle or coordinates and look for a new angle. As you can see, the motors are spinning to rotate it to its correct angle. Once it reaches the correct angle, it then will begin to move forward. You can see the motors are moving in the same direction, which will be driving it forward. Once it reaches its destination, it would scan and send the information back. This is not simulated. Now it is opening and closing the claw. As you can see, the motors will spin and change states as I activate each of the individual switches. After it has finished that sequence, it will now rotate 180, and you can see the motors are spinning. And once it has rotated 180, it will activate the pump motor, which will spray fire suppressant. Once that's complete, now it will ask for new coordinates, which in this case we'll put 0, 0, which is its home location. It will ask for a rotation angle. Again, the motors are spinning as it rotates. Once it reaches its current angle, it will drive forward until it has reached its home location. One of the requirements is that each of our individual robots need to work together in a swarm to complete the overall task. Our overall task is to contain a wildfire. The central hub would be responsible for sending all of the commands to each of the individual robots and receiving commands back when they are done. As you can see in this flowchart before you, the central hub would be responsible for deploying each of the robots and then waiting for the commands back that the robot has been completed. It would calculate all the pathing and sending the pathing information in simple X, Y, Z GPS coordinates. In addition to that, for the mop-up robot, it would be responsible for analyzing how best to clean up the lingering hotspots, be it driving over it with the treads to spread the ashes, or breaking it up with its claw and then dousing it with chemical suppression.
So, the firefighter robots is not a new concept. There are different kinds of robot in the market, but most of them are solo robots which perform different tasks or work on just a single task. So, as we're looking at this kind of designs from different companies, we took a different approach. We presented our swarm for the firefighter robot, which includes the design for the individual robots that has like designated tasks for themselves, which we saw that will be more effective on carrying out their own tasks. It's going to be faster, and in addition to overall deployment, it can provide more area and can also perform more tasks than what currently these companies has. And then this our design is undoubtedly can exceed expectation and help our firefighters save more lives, property, and also reduce costs and provide more budget to other projects or expenses for the time.
This project has taught all the team a lot. For example, it has taught us how to code, how to create CAD models, how to split work evenly and effectively within a team. If this were to happen again, we would do the following differently. We would look at the overall project, all three deliverables, before beginning to get a greater understanding of what is being asked of us. And we would brainstorm ideas for a longer period of time. We have covered the introduction with an overview of what the project entails, each robot's mechanical design, circuit design, code, and demonstration of abilities and how it functions. We have seen a flowchart of the communications of the robots and the central hub. Thank you.